So in our previous videos, we talked about the different learners that we'd be using initially in this course, and the two types right now are numeric prediction and classifiers. And so we discussed classifiers, and we went through how to do classifiers in Weka. And Weka makes that nice output tree and the decision tree, and then at each leaf we get a rule, and we can follow the tree down the different paths, and that seems pretty straightforward. So that was a classifier, and the other part I kind of glossed over a little bit, the numeric prediction, because Weka doesn't have as nice of an output for linear regression. So probably the easiest way to do linear regression is to do a little video here and show you exactly what happens when you do a linear regression. So linear regression, let me write that it's part of the family of learning known as numeric prediction. Okay. So let me draw a little XY coordinate system here, and it'll start to make sense why I'm doing this in a minute. And let's pretend it's an arrow. And so let's pretend that this represents home sales. So let me find a nice place to write this without. Okay, and then so on our x-axis we will have the square footage of our home, and then on this side we have the price of the home. And so say for example we went through and we collected a bunch of real estate data from some zip code, and say we had 10 or 20 or 30 different recent home sales, and we plotted them on our graph here. So we'd have our square footage and then our price, and so there would be an intersection of our XY coordinate plane. And so say we had a price here, price here, price so you get the general sense of what we're trying to accomplish here. And so what happens is we want to be able to come up with some sort of equation. That way, if I'm a real estate agent and I'm selling a new house, I have to look at the historical data, say this is for the past couple years, and I come up to my client and I want to tell them how much I think that their home can go for. And obviously this is a very simplified example, and this is actually what's known as simple linear regression, because we only have two parts to it. We just have our dependent variable and then our independent variable. And if you're not familiar with statistics, don't worry about that. Just think of it as two parts. Typically you'll have many more, and what that is called is a multiple regression. But for this example, this is fine. Let's just say all the homes are in pretty much similar condition, and they're from the same zip code, and all other factors are the same. The only thing is the home square footage, the size of it. And so what linear regression does is it runs it through this algorithm, and we do some processing and makes a line. Let's see, it's probably something like this. And so what I do as a real estate agent, I say, okay, let's say this right here is 2,000 square feet. And then I go up here and I go under the line and I mark this and I say, okay, let's mark it with a different color here. And then I go back over here and I go to the price and I say, okay, I think your price that you're going to get for a 2,000 square foot or 2,000 square foot home is $180,000. And so that's what this linear regression does. And as I mentioned, it's much it's often more complicated, but in a lot of things you can simplify it to this. So say, for example, you have you have a bunch of cows. Say you're a farmer, and you try to keep your cows all in the same condition, and the only thing that changes is their weight. So say, for example, this is their weight, and then you have a price you get for them from market, and they pay you per pound, and they come along, and depending on some of the other conditions, it won't fit this line exactly, but you may actually have a tighter fit that's something more like this around this line. So with real estate data, it varied a lot, but you might have a tighter line based on those prices. So I wanted to give you a visual example. So when you run this through Weka, that's what it does, and in the end, it actually gives you some linear equation for those that remember all this from your math courses. So it'll tend to look something like so this is your intercept here, and you have some line, and it follows that form of y equals mx plus b. And you won't really have to know that, but b is this intersect here, and then x would be your square footage, your independent variable, and then y would be your is a function of this, and so and then m is how steep this is. That's your slope. So that's where this all comes from, and maybe that now that you have a visual example, it'll drive it home a little bit more and make more sense to everyone.